Today's learning target is explaining electric and magnetic force. First, let's look at magnetic force. Remember that in a magnetic field, there's always a north and a south pole, and the magnets are strongest at the poles. Let's take a look at that. So here we've got two magnets. Here's my north end and my south end. Here's my north end and my south end. Now, if I push them close enough, they will connect. But I'm going to pull them far enough apart to where I can lay this note card over here, and I'm going to use some iron filings to show us where the magnet is the strongest. Now notice at my poles, that's where my filings are more concentrated. They're darker, they're thicker. And then in between at the poles here, you can see that there are still magnetic lines, even though if I lift this up, they're not touching, but there's still that attraction that's going on between them. Now, if I take the same magnets, but I turn them around to where south is next to south, you can see that they're repelling each other very strongly at the poles. So I'm going to stick them here, and when I do the filings this time, notice that I don't really have that attraction in the middle here. They're really pushing apart. Even when I try to push them together, it's pulling away because they don't want to be next to each other. Also, when you try to put a magnet together in the middle, you can see it automatically wants to push to the poles. So they're going to attract the strongest at the poles, and they're also going to repel the strongest at the poles. So that's magnetic force. Now we're going to talk about factors that affect electric force. And just like the north and south poles of a magnet, we have a positive and a negative charge on an atom. The positive is your proton, the electrons are the negative. So sometimes we will get charge that builds up on things, and that's how we get static electricity. So let's say you're walking across the carpet and your shoe starts to build up these negative charges on the bottom of your shoe. Then when you touch a doorknob, let's say this is our doorknob here, what kind of charge would we need to have on this doorknob in order for us to have that attraction force? Well, opposites attract, so we would expect to have the positive charge on the doorknob. And so whenever you touch that doorknob, then there's going to be that electric charge that happens. Now, when we're talking about things that affect the strength of the charge, first one is the amount. If I have this shoe that has several charges built up, and then I have another shoe that only has a couple of electrons built up on it, this one is going to be stronger just because it has more numbers of charges, okay? The next thing is the distance between the charges. If I am closer to the doorknob, the closer I am, the stronger that attraction is going to be. The farther away I am, even if I had the same number of charge, but I'm way over here, I'm going to have a much weaker charge because that doorknob is so much further away. So weaker when we have longer distance. All right, so those are our main factors that affect electric force, is the amount of charge, the number of charges that are built up, and the distance between the charge.